Hello everyone, today we'll be discussing kinetic particle theory. This theory essentially talks about matter in its three states: solid, liquid, and gas. For simplicity, we'll not be discussing other states of matter. So here are some animations for solids, liquids, and gases. This theory states that all matter can be described as particles in constant random motion. For solid, particles are closely packed and in an orderly arrangement. They vibrate about fixed positions. And for liquids, they are less closely packed, with no regular arrangement, and they can slide past one another. For gases, the particles are far apart from one another, and they move freely at high speeds. Okay, so now let's discuss the changes of state described by kinetic particle theory. So, if you melt a solid, it turns into a liquid. And if you boil a liquid, it turns into a gas. More keen observers would notice that boiling is not the only process that turns a liquid into a gas, and that would be correct. Another process is called evaporation. Evaporation is a passive process that occurs at all temperatures of a liquid. This occurs because of the random distribution of kinetic energies of particles of a liquid. Some particles near the surface of the liquid will have enough kinetic energy to overcome the attractive forces of attraction between the liquid particles, at the same time have enough energy to overcome atmospheric pressure. Thus, they are able to escape the body of the liquid into the atmosphere. There's a random distribution of kinetic energies between the particles of a liquid because when they collide with each other, they transfer kinetic energy between one another, resulting in some particles having higher kinetic energies and some particles having lower kinetic energies. Because those particles with a high kinetic energy leave the body of a liquid, the particles that get left behind have a lower kinetic energy. This results in the mean kinetic energy of the particles in the liquid to decrease. And because of this, the temperature of the liquid decreases as evaporation occurs. Now moving on, if we condense a gas, it forms a liquid, and if we freeze a liquid, it forms a solid. Other processes include sublimation and deposition. These processes skip the liquid phase and directly converts a solid to a gas or a gas to a solid. So, now let's imagine we have an unknown substance and we heat it. We will get a heating curve, as shown. So, the thermal energy supplied to the system does not result in an increase in temperature of the substance at the melting and boiling points, as it is used to overcome the attractive forces between particles. So, as you can see in the graph is horizontal at the melting point and at the boiling point. So, can you guess what substance this is? If you guess water, you're correct. This is the heating curve of water. So now let's discuss the cooling curve of water. So, as you can see, at the boiling point and at the freezing point of water, the temperature is constant because energy is released into surroundings to increase the strength of the forces of attraction between particles. It is worth noting that bond formation is an exothermic process. What does that mean? So, when bonds are formed, energy is released to the surroundings, while bond breaking is the opposite. It is an endothermic process, which means that energy is absorbed from the surroundings to break the bond. So, the curves shown are for pure substances only. So, what about for impure substance? Impure substances melt and boil over a range of temperatures. So, here we have the heating curve for salt water or brine. As you can see, at the melting point and at the boiling point, the graph is not horizontal, but rather it is sloped. Now, going to the last topic we're going to discuss in today's video, it is diffusion. So, kinetic particle theory describes diffusion. A consequence of the random movement of particles is that particles tend to move from a region of higher concentration to a region of lower concentration. Particles with a higher relative molecular mass will diffuse slower than particles with a lower relative molecular mass at the same temperature. This is because they have the same kinetic energy but different velocities due to their difference in mass. So, looking at the equation we have below, kinetic energy, abbreviated as Ke, is equivalent to half multiplied by the mass of the particle multiplied by velocity squared of the particle. You can observe if the mass of the particle increases in magnitude, velocity squared must decrease in magnitude for kinetic energy to be constant. For v squared to decrease in magnitude, the velocity of the particle v must decrease in magnitude. A heavier gas like chlorine gas with a relative molecular mass of 70 will diffuse slower than a lighter gas like hydrogen gas with a relative molecular mass of 2 at the same temperature. And thank you for watching. I hope that this video will help you in your revision and in better understanding kinetic particle theory. I wish you a good day.